Hi students, welcome back. Today we are going to look at the product of array except self problem on LeetCode. So let's look at the problem statement first. So the problem statement says we are given an integer array numbers. We have to return a answers array such that answer at ith position is equal to product of all elements of the numbers except nems of I. That means answer at I should be equal to the product of every other element in the I except the element at that position. Okay. The product of any prefix or suffix of nums is guaranteed to be 32-bit integer. So here they are just saying that it will fit in a integer. You must write an algorithm that runs in order of n time and without using the division operation. So division operation is not allowed. We cannot just do the entire product of the array and at each point do product by the current element. This will definitely give the solution, but since division operation is not allowed, we cannot do that. Okay, and the other thing is you have to do it in order of n time. So clearly in n square you can do it. You can say ki for I equal to 1 to n. Okay, and again take another loop for j 1 to n. Whenever I not equal to j, you find the product and that would be your result. So you'll do this only when I not equal to j. But we have to do it in order of n square. So this brute force solution is also not a valid one. Okay. So let's look at the given examples. Let's understand the problem first. Okay. So the given example says the input array is 1, 2, 3, and 4. Okay. And the answer is, so at position 0, the answer would be 2 into 3 into 4, which would be 3 to 6, 6 4 is 24. Okay. And at position 1, the answer would be 4 3 is 12 into 1. Okay. So 12. At position 2, answer would be 1 into 2 into 4, which is 8. And at position 4, it would be 1 into 2 into 3, which is 6. Okay. So this is our answer. Okay. And in the next input, we have 0 in the mix. So when you have 0, all the other positions will be 0 because at every other position you have to multiply by 0 and you will get a 0. Only at 0, if you find it, it would be minus 1 into 1, which is 1, minus 3, which is minus 1, minus 3 into 3 is minus 9, minus 9 into minus 1 is 9. Okay. So this is the answer. So let's look at how we can solve this problem. Okay. Let's take a different example and see how we can solve this. Okay. Let's say our input array is 2, 3, 4, and 5. Okay. So clearly the n square solution where you traverse the array and at every point you multiply remaining elements, which is n square solution, is not allowed. And you can also not do something like in order of n, find the total product. Okay, all product of all elements, and in another order of n you could do product by I, but since division is not allowed, we cannot do this as well. Okay, so now what can we do? So we have to find the product of if you break down the solution, actually what you're saying is you have to find the product. Let's say if you're looking at 3, you have to find the product of all its prefixes, product of all its suffixes. So let's try to look at it that way. Okay. To find the value of the prefix, product of all the prefixes at the current point and product of all the suffixes at the current point, and we multiply both of them to get the value at the current position. So let's find all the product of all the prefixes for every point in the array. So let's take a variable called current, which basically holds the product of all the elements till this point. So when I equal to z, initially let's initialize with 1. So when I equal to 0, so the product of all the prefixes is, there are no prefixes for I equal to 1. So it will still be 1. But going forward, we need the product of all the values till this point. So let's update current with current into the current value of I, which is 2. So 1 into 2, current becomes 2. So at I equal to 1, at I equal to 0, all these will still stay as 1. Okay. At I equal to 1, what happens is, for the result, we want it to be the sum of all the prefixes, which is already there in the current. So we just update the result with 2, and we also update the result current with the current product, which will be 2 into 3, the current product into 3. So 3 to 6. Okay. Rest are still not processed. They'll still stay as is. Now, when I equal to 2, the product of all its prefixes would be whatever is there in the current, which is 6. But we have to also update the current, which would be 6 fours, 24. Okay. Now, when I equal to 3, this becomes whatever is in the current, which will be the previous product, and the current becomes 24 into 5. But since we reach the end of loop, we are anyway not interested in that. So what we have done so far, at every point, we have found the product of all its prefixes. The first position doesn't have any prefix, so that is why the product is 1. Second position, the product of first one. In the third position, product of 1 and 2. Fourth position, product of 1, 2, 3. Okay. Product of 1, 2, 3, which is 2 into 3 into 4. Okay. So we have all the prefixes. Now let's find all the suffixes as well. And while doing the suffix, let's also update prefix into suffix because we already have them. So when you are finding the suffix, you are multiplying with whatever is on your right. So let's start with the highest point in the array, which in this case is I equal to 3. So our current result array is like this: 1, 2, 6, 24. Okay. Let's take the current variable, which will have product of all the elements on its right. So which will have the product of all the suffixes till the current point. So when I equal to 3, okay, when I equal to 3, what happens? The current value is still 1. So you don't have anything on the right. So during the suffix calculation, what we did, we just updated the current value. But here we have to multiply it with whatever is there in the suffix to get the result. So here the prefix value is 1, which is whatever is there in current. Suffix value is 24. And our answer would be 24 into 1, which would still be 24. Okay. 6, 2, 1. Now, when I equal to 2, we move here. So before moving here, we also have to update the product, right? So the product becomes 1 into nums of 3, which is 5. So the product becomes 5. So the sum of all the suffixes till this point is 5. So at I equal to 2, sorry, not sum, product. Product of all the suffixes is 5 and product of all the prefixes is 6. So the result is suffix into prefix, which is 30. Okay. And similarly, we have to update current to product of all the suffixes, which would, this will become 20. Okay. Now when I equal to 1. So at this point, this is already processed. In this iteration, we didn't touch these two. Okay. So here, this will carry as is, and we are finding the value here. So this would be sum of all the suffixes, which is 20, and sum of all the prefixes, which is 2. So 40. Okay. And let's update the product of suffixes as well. So at this point, product of suffixes is 60. It is 5 into 4 into 3. Okay. This we are not processing in this iteration. Now, when I equal to 0, we are not touching this. We are processing this value. So again, it would be sum of all its suffixes. which is 60 into sum, sorry, not sum again, product of all its suffixes, which is 60 into product of all its suffixes, which is 1. So product of all its suffixes is 60, product of all its prefixes is 1, 60 into 1, this would be 60. So what we have essentially done is, in one iteration we have found the product of all the prefixes. In the second iteration, using the current variable, we are finding the product of all its suffixes and multiplying it with the suffix value, prefix value to get the result. Okay, let's write code for this. So if you understand the logic, this is actually pretty simple. You are just calculating the prefix and suffix. Okay, yeah. So initially, let's just get the size of the array here. Size is guaranteed to be at least 2, so we don't have to do any size checks. So let's initialize a result array which carries our answer. Okay. Now, initially, let's fill this result array with 1. Okay. So that when you do a product, it will be fine. And we want a current element. At this point, we are finding the product of prefixes. So we'll start with I equal to 0, I less than n, I plus plus. So we are saying that the current will hold the product of all its prefixes. So result of I just becomes current. Okay. We have to update current for the next iteration, which is why current becomes current into nums of I. Okay, so what we are essentially doing is current is carrying all the products till that point. We are just updating it. Now, after this, we will have the product of all its suffixes in the result array. Okay, now we have to find the product of, sorry, we'll have product of all the prefixes in the result array. Now we have to find the product of suffix. So let's initialize current to 1 again. Okay, when you are finding the prefix product, we will start from end of the array and we will go till 0. Okay, so result of I would be, so in case of a prefix, we just did current. Okay, here we have to do current into result of I. So current carries the suffix product, result of I carries the prefix product. So to get the actual answer, we have to multiply both. And we have to update current to carry the product of all its suffixes. So current would be current into nums of I. Okay. So here we found the all the prefix products. Here we are finding the suffix product and we are also multiplying with the whatever we found in the previous loop. Okay. So finally we'll have our answer in the result. Okay. Let's run this and see. So what would be the time complexity of this? So there were two conditions in the algorithm, in the program. It said it should run in order of n time. Okay. So here we are running the loop twice, but it's still order of n. Okay. What is the problem here for? Okay, we have to do for n time. It's still order of n. So we satisfy that condition. And the other condition we had was we shouldn't be using division. We are not using division anywhere. So the time complexity is order of 2n, which is essentially n because we don't consider constants. And the space complexity is, if you don't consider the result array in the space complexity, it is constant space. Other than the result, we are not using any external space here. Okay, let's submit this and see. Yeah, so this works. So that's all we have for this video. So do practice it and do a dry run, that will give you a clear understanding. Thank you for joining. Happy coding.